Okay, so the question is, a block of mass m is being pulled along a rough horizontal surface by a constant applied force of magnitude F1 that acts at an angle theta to the horizontal. The acceleration of the block is a1. Express all algebraic answers in terms of m, f1, theta, and a1. So the first question is, draw and label a free body diagram showing all the forces on the block. So first of all, we can begin by drawing a dot representing the block. And we know that any mass that is on Earth has a force of gravity. We can label that Fg. We also know that any object that is resting on a surface has a normal force that is equal and opposite to Fg, the force of gravity. And this is the force that the surface applies to the block. Now these are equal because we know that the block is not moving up or down, so there's no net force in the x direction, so we know that Fn is equal to Fg, so we can draw two lines representing that they're equal. Okay, so the next force is F1, so we could just draw that here. And since this is a rough horizontal surface, there is a force of friction that is always applied in the opposite direction of motion. So it is this way. This is the force of friction. So the question is, derive an expression for the normal force exerted by the surface on the block. So the normal force is Fn pointed upward right there. Okay, so we can start off by saying that the net force in the y direction is equal to 0, since the block is not accelerating upward or downward. Next we can say that upward can be positive and downward can be negative. So we can write a force equation. So our force equation will look like Fn plus the component of F1, the y component of F1, which will be F1 sine theta. And then we have to subtract the force of gravity, since the force of gravity is downward. And this is equal to 0, since the net force in the y direction is equal to 0. Okay, now we can rearrange this equation to solve for Fn. So we have Fn equals Fg minus F1 sine theta. Okay, now we know that Fg is equal to mg, mass times gravity. So Fn equals mg minus F1 sine theta. And this is the answer. That is Fn. So the next question is, derive an expression for the coefficient of kinetic friction mu between the block and the surface. So this time we can create a force equation, but in the x direction. We know that the net force in the x direction equals ma1. And the forces acting in the x direction are the x component of F1 and the force of friction. So the x component of F1 is F1 cosine theta. And so the forces to the right we can say are positive, and the forces to the left we can say are negative. So we have to subtract the force of friction, and this is all equal to ma1. Now we can rearrange this equation to isolate the force of friction, and we get F1 cosine theta minus ma1 equals the force of friction. Now we also know that the force of friction equals mu times Fm. So we can write that down, F1 cosine theta minus ma1 equals mu times Fn. And we know Fn because we calculated that in the previous question, B. So we can write F1 cosine theta minus ma1 equals mu times mg minus F1 sine theta. And this is what we found in the previous question. So we can divide by this and get our final answer, which is mu equals F1 cosine theta minus ma1 over mg minus f1 sine theta. So this is the answer. That is mu. So the last question, D, is sketch the graphs of the speed v and displacement x of the block as a function of time t if the block started from rest at x equals 0 and t equals 0. Okay, so first of all, we know that the block has a net force acting on it, so it has to be accelerating. So the velocity versus time graph cannot be just a straight line because the velocity is not constant, it's accelerating. We also know that the acceleration is constant, so the velocity versus time graph can't be a curve. It has to be just a straight line showing that the velocity is constantly increasing and it has a constant acceleration. So the displacement versus time graph cannot be a straight horizontal line because we know the block is moving. It also can't be a straight linear line because that would indicate that the velocity is constant, but the velocity is not constant. It's accelerating, and so since the block is accelerating, the displacement versus time graph is an exponential curve.